All right, so we've been talking about the unit circle here, and over the past couple of days we've been talking about the patterns and how we go ahead and create these. Well, you'll notice I've already got all the degree measures. I've got all the radian measures, and again, just to kind of review, if it's on an axis, remember that was a quarter of a revolution, so that's why those are in increments of 90 all the way around. We've seen that before. The 3 points clustered together in each of the quadrants. Remember they were 15 degrees off of each other, but 30 off the axes. How'd we quickly get those radian measures? What'd we do? If it was a multiple of 45, we counted by 1/4, right? So see, we had 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi, all the way around to 8/4 pi, which is my 2 pi. And remember, we do want to simplify. If it was a multiple of 30, we're going to what? Count by 1/6. So 1/6 pi, 2/6 pi, 3/6 pi, 4/6, 5/6, all the way around to 12/6. Again, you get your 2 pi. All right. Now, we did talk a little bit yesterday about the right triangles, how they would help me get the points on the unit circle if I really wanted those. And Lilybell was really excited about that. I remember by the end of the lesson. But there was another way I showed you at the end, a shortcut. Because all 12 of these points, they were all doing the same thing. They were being divided by what? They were being divided by 2, yes. So let me go ahead and set this up. So 2, 2, 2, 2, and 2, 2. Okay. There you go. On the inside track, the one closest to the circle, you'll go ahead and start up here, go 1, 2, 3, and then you'll just count back up again. 1, 2, 3. And then on the numerators, you take the square root. But the square root of 1 is 1, so we don't have to worry about that. And there you go. In seconds, you'll have those 3 ordered pairs right there. Okay. Now, how does that help me with, say, the other ones? Like, what about these 3 points here in quadrant 2? What can I do with those in quadrant 1? Yeah, all you're going to do is flip it. You're just going to reflect it over. Imagine that I could fold it right along the y-axis. So all that's going to happen is that those x values are going to change sign. So 60 corresponds to 120. So this one would be negative 1/2 square root of 3 over 2. And then we reflect over the 45 degrees, negative square root of 2 over 2, square root of 2 over 2. And then we have our last one here, negative square root of 3 over 2, 1/2. Okay, so that works out nicely. I can also take those exact points from quadrant 1, fold on the x-axis. Okay, just reflect those guys down. So 60 degrees would correspond to 300 degrees. So how would this point at 1/2 square root of 3 over 2 change? Yeah, now it's the y being negative. So this would be 1/2 negative square root of 3 over 2. The 45 would correspond to the 315, which would be square root of 2 over 2, negative square root of 2 over 2. And then our last one here, square root of 3 over 2, negative 1/2. Okay. You see, very quickly, just by using the symmetry, we can get those ordered pairs very, very quickly. Okay. Now, what about this third quadrant here? They're both going to be negative, yeah. So let's see here. You could either go ahead and reflect the second quadrant or the fourth one, however you want to. But the 150 would correspond to the 210. So I'd be looking at this point. Negative square root of 3 over 2, negative 1/2. Then the next one, if I reflected, negative square root of 2 over 2, negative square root of 2 over 2. And then we finish up negative 1/2, negative square root of 3 over 2, just like that. Okay. Now, for a good while, we're only going to be limiting ourselves to these points. Now, there are 16. I've only taken care of 12 of them right now, but eventually we are going to move forward. So all of these values we're going to have an ordered pair for. Because remember, on your quizzes and your tests, you can do what? You can use your notes. Okay, absolutely. Now, those other 4 that I haven't gotten to yet, what do we call it if the angle. We go ahead and start to rotate here in standard position. What if it stops on an axis? Remember what we call that? Oh, not an intercept. Starts with a Q. Oh, we're actually close. Quadrantal. Remember, we call those quadrantals. Well, why do we call this the unit circle? Yeah, the radius is just 1 unit long, right? So these 4 quadrantals, those are going to be the easiest points of all. So this one right here would be 1, 0. This point here would be 0, 1, negative 1, 0, 0, negative 1. There we go. Okay, just like that. Okay, perfect, perfect, perfect. And what I might do at some point, once we get past some triangles, for the unit circle, I might go ahead and start throwing that in for your happy minutes. Not necessarily the entire triangle, but I might ask you to go ahead and do like the first quadrant. Okay, and then maybe the next time, first and second quadrant, see how far we can get. Okay. So good, 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 good. That's the unit circle. Does anybody have any questions on that? No? Everybody feels pretty confident? And then, of course, here's one that's all nice and typed up. Okay. If anybody wants a copy of this, I can go ahead and get that to them. Would anybody want a copy? Okay. Then I'll go ahead and make some copies during my conference period. I'll have those ready for you come Tuesday. You guys remember you have a 3-day weekend, right? Yeah. So, nice. Okay. What's that? You get a 4-day weekend? Not coming Tuesday? Not even for your favorite class? Oh, he got me with that one. Okay. Okay, so let's go ahead and start taking a look at this. All right, so this is trig functions on the unit circle. Go ahead and take that off there. So this is the packet I had yesterday. They are over here next to Jason and Adolfo. Okay, if anybody wants to grab one. So at this point, we're going to go ahead and start to move away from the side lengths we call adjacent, opposite, and hypotenuse. We're going to go ahead and start taking a look at these in terms of ordered pairs. X is the horizontal distance you move, Y is the vertical distance. Okay, so here, sine of theta, it's no longer going to be opposite over hypotenuse. We're going to go ahead and say it's Y over R. What do you think R stands for? R is the radius, yeah. Okay, so let me go ahead and show you one. There's another example right here, but let's say we have an angle, okay, theta, that rotates me where I stop in quadrant 1. There's my terminal side right there. Well, I'm going to go ahead and drop a segment to make a right triangle to the x-axis, just like we were doing with the unit circle. Okay. Now, this point right here that we went ahead and dropped the line from, that's a point on our circle. Okay. So let's imagine, if I want to go from the origin 0, 0 to this point right here, well, I've got to move horizontally x, then I've got to move vertically y, right? And then, of course, we have our radius. So that's all we're saying. We're still going to be dealing with right triangles, but we're going to be looking at them in terms of those distances on the triangle. Okay, the horizontal x, the vertical y, and then the radius. So sine would still be y over r. Cosine adjacent over hypotenuse would now become the adjacent x over the hypotenuse r. Okay. Tangent opposite over adjacent, opposite y over adjacent x, and then the reciprocals are just going to follow suit. Okay, they're just going to be taking the reciprocal of those ratios. Now, it does say make sure you know which quadrants the functions are positive or negative. So let me come on down here and show you this. There's a quick and easy way to go ahead and remember in what quadrants the trig functions are going to be positive. You just say all students take calculus. All students take calculus. So the first letter of each word tells you what trig function is going to be positive there. Now, the only exception is the A for all. That actually does stand for all. All 6 of them are always positive in the first quadrant. Okay, but the S stands for sine, T stands for tangent, and C stands for cosine. Just like you would, number the quadrants, 1, 2, 3, 4, counterclockwise, you say the sentence in the same way. Now, you'll notice along with sine, tangent, and cosine, well, what's also in a quadrant with them? They're reciprocals, and it makes sense, right? Because let's say you have a number, let's say a positive 5, and I take the reciprocal. Well, what's the reciprocal of 5? 1/5. Its reciprocal is still positive, right? So wherever sine is positive, cosecant is going to be positive as well. Same thing for tangent, cotangent, cosine, and secant. Now this is also very useful to you because if we know where these trig functions are positive, do we also know where they're negative? Yeah. So for example, based on what I have here, what 2 quadrants would tangent be negative? 2 and 4. Because I can see from here that tangent's going to be positive in 1 and 3, so that means it has to be negative in 2 and 4. It's always going to be positive in 2 quadrants, negative in 2 other quadrants. Okay. All students take calculus. Does that make sense? Okay. So we want to be thinking about those trig functions, when we begin to evaluate them, because that's going to be real important. Excuse me. So let's say we take a look at this. Let -4, 3 be a point on the terminal side of an angle theta in standard position. Find the exact values of the 6 trig functions of theta. Now this is something that we're already used to doing. It's just we have to create the triangle now. Let me show you what I mean. So we have -4, 3. I'm going to create a coordinate system, just an XY plane. And we're looking at -4, 3, right? Well, think about if you were to go ahead and plot a point starting from the origin, what quadrant would this guy be in? It'd be in quadrant 2, right? Because from the origin, you'd go 4 left and 3 up. So let's say that point is right here. Okay, 4 left and you went 3 up. Well, what we're saying is you're going to start in standard position and you're going to begin to rotate so that when your terminal side stops, that point is on it. So this is my terminal side. So we rotated some measure of degrees. Okay. And now your reference angle is where you're going to go ahead and place theta. Now this is important. What does that mean, reference angle? It's the angle created between what 2 sides? Ooh. One of them starts with a T. What's that we just rotated? The terminal and the closest x-axis. Okay. Now what we're going to do, that point is on the terminal side, right? That's the point I'm going to use to go ahead and drop a line and make it perpendicular to x. See, I'm going to use him to create a right triangle. Now, do we know the sides of the triangle? Well, that's a good idea, but we don't know if it's a special right triangle. But think about it. I wanted to start here at the origin and get to this point. So I had to go -4 units left and then 3 up, right? And here's the thing, I don't want to confuse you. We're not saying that the base of this triangle is actually -4 units long. The negative just tells me direction. Because without the negative, I would have gone 4 right, correct? Okay. Now, I like to go ahead and have those in the diagram just so I don't forget. It's really easy to forget a negative. Okay. Now, I've got 2 sides. Well, what can I do to find the other side? Yeah, Pythagorean theorem. So let's say that r is my radius, 3 squared. And if you know your triples, yeah, that's exactly right. -4 squared is equal to r squared. So that would be 9 plus 16 is equal to r squared. 25 is equal to r squared. So r equals 5. Okay. So what I'm going to do, I used that point to create a right triangle. And now this is exactly what you just did on your happy minutes a few minutes ago. I just want to find the value of all 6 of those trig functions. For example, starting with sine of theta. Now, if you want to label the sides, like we did before, it's just that now the horizontal is x, it's not the adjacent. The vertical is the y, no longer opposite. And we're saying that the hypotenuse is r. Now remember, sine's ratio was to take y over r. So that would just be 3/5. There you go. Excuse me. Just like that. And then we just go ahead and find the rest of them. What was cosine's ratio? It was x over r. Okay, so x over r will give me what? Negative 4 over 5. Perfect. And tangent, his ratio was y over x. And what's y over x? 3 over negative 4. Okay, so I'm going to go ahead and rewrite that as a negative 3/4. Here's my... Oh, it's right in front of me. Throat's kind of scratchy today. Okay. But is anybody having any trouble seeing what I'm doing? Okay. All right. Well, let's go ahead and find the rest of them, starting with cosecant. Now, cosecant was r over y. So I can either look at the diagram or just take the reciprocal of sine. Either way, I'm going to get 5/3. Yeah. Then secant of theta, well, that would be r over x, which would be what? The radius over negative, oops, I'm going to start to say it. So 5 over negative 4, so I'll say a negative 5/4. And then our last one, cotangent of theta, well, that is x over y, so it's a negative 4/3. And there you go. You create the triangle using the point that you were given. Okay. Does anybody have any questions on that? Okay. All right. Well, let's try this next one. Now, we are going to change it. You'll notice the point you have on your paper, I want to go ahead and rewrite this as 3 negative 6. Okay, we're going to change that just a little bit. So our point is 3 negative 6. Okay, let me erase this right here. Okay. Okay, so I'm going to do the exact same thing. The problem says let 3 negative 6 be a point on the terminal side of an angle theta in standard position. Find the exact values of those 6 trig functions. Okay, so what quadrant is 3 negative 6 going to be in? Yeah, it's going to be in 4. So that just means we rotate all the way around some angle theta. We don't know what theta is, and that's perfectly fine. But the terminal side is going to be in the 4th quadrant because that's where that coordinate would be. 3 negative 6. Okay. So I've got a terminal side with that point on it. Okay, now what? Okay. Now theta becomes my what? The reference angle. So where I decide to put that point, I'm going to connect it to the x-axis. I'm going to make my right triangle. And like you said, theta is my reference angle. It's created between the terminal and the closest x-axis. Now, because of the point, do we actually know what the legs of the triangle are? Yeah. The horizontal is 3, because I had to go 3 right, and then we went 6 down. So the negative, again, just tells me direction. Okay. So let's go ahead and figure out what r is. Okay, again, we're going to use the Pythagorean theorem. So 3 squared plus a negative 6 squared is equal to r squared. So that's going to give me 9 plus 36. What would that be? 45. Okay, good, good, good. And here's the thing, we don't want to go decimal. If it's not going to be a perfect square like the previous one, then we just want to see if we can work with him. Okay. Now, he already told me 3 square roots of 5, so how did he simplify that? What did he do? What's the largest perfect square that evenly divides 45? 9, right? So I can just rewrite it. This is 9 times 5. Now, see, I can take the square root of 9, but I can't take the square root of 5 without getting a decimal, so he's got to stay where he is. This is 3 square root of 5. Okay. Is everybody okay with how I got that? Okay. And then we just go ahead and find those 6 trig functions again, just like we did before. And if you want to label your sides, perfectly fine. This would be my x, this is the y, this is the r. Okay. So sine of theta. What was sine's ratio again? I keep forgetting these things. Y over R. So the Y is -6 over what? 3 square roots of 5. And what's that? Yes. So if we have a radical down below, we're going to rationalize. Mm-hmm. Mm-hmm. And if this first one I'm going to go ahead and write out. If anybody wants me to continue writing them out, please let me know. But the -6 divided by 3, that part just becomes -2, right? So I'm going to go ahead and multiply this by square root of 5, square root of 5. So it looks like my final answer is going to be a -2 square root of 5 over what? Oh, not 1. 5. There we go. So see, we didn't have to do this on the previous one because it was a perfect root. So I would say this problem is pretty radical. Yeah. Next up, cosine. Okay, so cosine, I remember, was x over r. So I'm going to take the x, 3, over the radius, again, we just found 3 square roots of 5. There you go. See, once those 3's cancel, you got 1 over the square root of 5. If you're to multiply both parts, you do get square root of 5 over 5. Now, if anybody, like I said, wants me to write out to show how we're getting that final answer, I'll go ahead and do it. If you guys feel comfortable enough just looking at it and saying, okay, that answer has got to be square root of 5 over 5, just let me know. Does anybody want me to write that out? No? Okay. Well, what about tangent? Let's see. Tangent of theta, that was y over x. Yeah. So -6 over 3, which is just -2. That one we don't have to rationalize. The sides involved did not have radicals. Okay. And we just keep going. Cosecant. Okay. So it's r over y. He's absolutely right. Brandon says 3 square roots of 5 over -6. Now this one we don't have to rationalize, but it would be negative square root of 5 over 2. Okay, negative square root of 5 over 2, because the 3/6 would reduce. Perfect, 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 perfect. Okay. Now, we're almost done. Secant. So that is what over what? Okay, so r over x, 3 square root of 5 over 3. Okay, so yeah, just square root of 5. That's exactly right. On that, if if the only thing left in the denominator is 1, I'd probably just leave it as is. Angel? Oh, did I make a mistake? No? Okay, just telling me, way to seek it, Mr. West. Well, you're about to go 3 days. I mean, that's a long time with no math, right? Andrea's like, absolutely. I know what you're talking about. Okay. Last up, cotangent of theta. Yeah, this one here, just the reciprocal of tangent, or, look at your diagram. Either way, -1/2. That's it. How are we doing? Anybody having a hard time? Okay, Brandon, what can I do? How do I reduce? Like on which one? Okay, so let me write it out again. We had -6 over 3 square root of 5. Okay, so -6 over 3 square root of 5. Well, both the 3 and the 6, they're divisible by what? Okay, well now it becomes 2, but see, 3 will divide into itself one time, but 3 will divide into -6 twice. So then we had the -2 over the square root of 5. So it's just like, just like before, the -6/3 became -2. Okay. Does that make sense? Okay. Kind of. So if I were to give you something like, I don't know, 14/18, what would that become? There you go, because they're both divisible by 2. That's the largest value that divides both of them. So that's just what we're doing here. Okay. All right. Does that make sense? Okay. Good, 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 good. Okay. You want me to go ahead and do one more? Like 17/34? Uh-huh. Oh, yeah, whatever the largest factor is they're both divisible by, that's what you do. That's very possible. Like you could end up with something, like 3 square root of 2 over 7. Like the 3/7 won't do anything. He's got to stay as is. Okay. So what would the 17/34 be? 1 over 2. Okay. In fact, I would have really liked to have chosen 17/38. I said, hey, what's up? Hello. But see, there you go. I got a laugh out of her. Okay.
Too early for this.
But 17/38 wouldn't have reduced, and I would have had, had anything to say. What's the new dance now? Is that the floss?
What? Oh, the floss.
Did I see a lot of people doing?
There we go.
Do the what? What's the shoe?
Yeah, that's the shoe.
What, like your what? You I don't know what that is. Okay. So just search it on YouTube. There you go. I know all the popular dances like rolling the dice. You can't do that anymore? Why not? That's what?
It's called playing dice.
Playing dice? Oh, okay. Or packing the groceries. Whatever, I'm old. Okay. Lucky this is one of those times I'm not being recorded. This is my sound, so people at home will have to kind of just imagine that happening. Okay. All right. Well, this is how we're going to go ahead and stop today. I just want you to go ahead and start thinking, we have these ratios here, but, when we plot a point, we're very accustomed, and it just isn't in your notes, so you just kind of follow along. We really like our ordered pairs to be x comma y, right? This is not in your notes. This is just something I went ahead and put up extra, kind of a way to finish out the lesson today. We like our points to be x comma y, right? The horizontal and then the vertical. Well, when we're talking about the unit circle, the points on the circle itself, we're going to be looking at those in terms of cosine and sine. X is the cosine, y is the sine of the function. Okay. Now, when you think about it, this kind of makes sense. Because all we're doing, this is the x-axis, this is the y-axis. So this is the origin right here, right? So all I'm doing, that unit circle that we've been talking about, I'm just placing him right on top of the xy grid, right? So that the center and the origin are both one point. So what I'm trying to get you to understand now is that any point on the circle, we're not going to be calling it xy. We're going to be calling it cosine of theta, sine of theta. Okay? And let me show you how we actually get this. Let's say this point right here, I go ahead and drop a segment down and create a right triangle. Okay? Now, it doesn't matter what the angle is. I mean, we would know that's 30 degrees, but let's just say it's just some triangle for any point on the circle, right? Okay? Well, in order to get from the origin to that point, you got to move x horizontally, y vertically, and then you got your radius, right? Well, now, this is why we're looking at the cosine, all the other trig functions in terms of these lengths. What was cosine's ratio? So adjacent over hypotenuse, so what do we call them now? X over r, right? So let's say I wanted to solve this for x, and we've actually done that, quite a few times. I would just multiply both sides by r so that those cancel, so you have r times the cosine of theta equals x, right? But we're on the unit circle. So what's the length of the radius? Remember, the radius is 1. So what's 1 times the cosine of theta? That's just cosine of theta. So I can replace x with cosine if we're just on the unit circle. The same thing is going to happen for y. if I were to go ahead and say sine of theta, and what's its ratio? Opposite over hypotenuse, so y over r, right? But we don't even need to solve for y. Remember, what's the radius? 1. So if I replace that with 1, what's y divided by 1? Yeah. So sine of theta is just y. Oh, are you asking why or is it what? Okay. So we're going to go ahead and play off this idea Tuesday when I see you next. How's everybody doing? Yes. You want to scroll up? Oh, yeah, yeah. Does anybody want to take a picture of that real fast? Get your phones out. Okay. It's math. That's got to look hard. What, like Captain Morgan? What?
Look up the.
Yeah, that's weird. Okay. Okay. You got the shoe? Oh, the shoe. Oh, okay. Okay, so look up the shoe. We got 5 minutes. Why don't I go ahead and do that? Let me go ahead and